Here we go. All right, review from yesterday. If you were not here, we need some notes. Okay? We're talking about the pH and the pOH scale. pH is power of hydrogens. pOH is power of hydroniums. Our acid-base scale runs from 0 through 14. 7 is neutral. Anything below it's acidic. Anything above it is basic. If we take a look at our scale and what this actually means in terms of concentration or molarity, we run from 7 down to 6. We're going from 7 to 6, we are 10 times more acidic. So every number, we're going to be multiplying by 10. If we go from 7 all the way down to 4, 7 to 6 would be 10, 6 to 5 would be 10, 5 to 4 would be another power of 10. 10 times 10 times 10. 10 times 10 is 100, times it by 10 is 1,000. 4 is 1,000 times more acidic than 7. If we're talking about the opposite way, 7, even though it is neutral, is 1,000 times more basic than 4 is. Okay? The other way to consider this, if we're going 1, 2, 3, this is 10 to the third power. 1 times 10 to the third power would be 1,000. Okay? If we go the opposite way, 7 all the way up to 11. We're jumping to 8 to 9 to 10 to 11. Okay? So that would be like 4 jumps. This time, however, we're more basic. So 1 times 10 to the fourth power would end up being 10,000. 11 is 10,000 times more basic than 7 is. Okay? Another one, using two acidic numbers. If we're looking at 2 and 6, these are both acids, okay, but 2 is a much stronger acid. So from 2 up to 3 to 4 to 5 to 6, that's 4 jumps. 1 times 10 to the fourth power is 10,000. 6 is 10,000 times more basic than 2. Even though this is an acid, it's closer this direction, making it more basic. They're both considered acids, however. All right, so we did 2 different types of equations yesterday. Okay, if you're given either the pH or the pOH, we're going to follow these steps. Okay, this is going to tell you how to calculate molarity. If you don't have these, pause the video and make sure you just write all these down. So let's just say we had a pH of 5, and we want to figure out what our concentration is. Okay, on your calculadora, okay, we're going to hit the Shift key with an F. Then we're going to hit the 10 of X. You're then going to hit the negative key, type in whatever number pH you have, and hit equals. Shift 10 of X, negative, and we're going to do 5 here. Boop. And our answer is 1 times 10 to the negative 5th. This is our concentration of hydroniums. If we take that out of scientific notation, we're moving it 1, 2, 3, 4, 5. Okay, so these are the same number. All right, so if we do it the opposite way, this is equation B. If you're given molarity and you'd like to calculate the pH or the pOH, we're going to be doing this on the calculator. So how we do this is first type in negative, then you hit your log key. Then we want to put your number in parentheses. Okay, so you'll close your parentheses. We'll type in 3.2, exponent key, raise it to the negative 4th power, close your parentheses, and that'll get you your pH. So let's just show you how to do that. Negative, log, parentheses, 3.2, exponent, negative 4, close your parentheses. Boom. All right, there we have 3.49, or a power of 3.5. Okay, so that's what we reviewed yesterday in the notes. So now let's do some practice problems. So let's take a look here. And let's do some of the ones closer towards the bottom. Okay, so number 9. If we're looking at number 9, right now we know our pOH scale. And this is 13. These two numbers must always add up to 14. So 14 minus 13 is going to get us 1. pH is what we're going to use to tell if it's acid, neutral, or basic. We know that 1 tells us that we're an acid. Okay? And now we're going to take this and figure out our concentration. If we're given the pH, then we're going to be doing equation A. So I go back to my notes. You're going to need your notes in order to take the quiz. I don't expect you guys to memorize this. If you don't have your notes, you're going to be out of luck. So I'm now going to hit Shift 10 to the X, -1, and there we go, 0.1. That's my concentration of hydrogens or hydroniums, 0.1. If we wanted to write that in scientific notation, 1 times 10 to the -1st power. So now I want to figure out my concentration of hydroxides. Okay, I have to use this number. Once again, I was given pOH. So same thing, if we take a look here, I want to figure out molarity. So I'm looking up here, how to calculate molarity. I was given the pOH. So we're doing the same thing here, just with our new number. Shift 10 to the X, negative, and I'm typing in 13, boom. 1 times 10 to the -13th power. And this should be M, capital M for molarity. Okay? This concentration of hydroniums is much higher than this very, 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 very small number. That's why this is an acidic guy. Let's do an opposite one. Let's do one where we have to do equation B. So let's take a look at equation 7. Okay? So here, now we're giving our molarity. We've been given our concentration. So if I'm given the molarity, I'm now doing equation B. Okay? We want to figure out how I get my pH or my pOH. So what we're going to do here, negative log parentheses, and my number is 1.0 exponent to the -5th. Close the parentheses, and equals 5. Okay, so we just figured out that our pOH is 5. To calculate our pH, these two numbers, once again, have to add up to 14. So 14 minus 5 is going to get us 9. Ooh, look, I'm right. Now that we have our pH, once again, we're going to do the same equation to figure out our concentration of hydroniums. Same one. So once again, we're going to be using equation B. And if you haven't figured out yet, anytime you don't have a decimal point, okay, such as this one here or number 4, okay, if our first number is 1, all we're going to do here, it's going to be 1 times 10 to the -9th. Okay. Now we have two numbers to look at here. We need to use the first one, the pH scale, to figure out if we're acidic or basic. Because this is more than 7, this would be a basic solution.